Welcome to this webinar on PSE Petroleum Structural Engineering software, a specialized structural analysis and design tool built exclusively for the oil and gas industry, covering onshore and offshore drilling structures such as platforms, rigs, masts, and substructures. PSE is built around a modern ribbon-based interface that keeps your workflow intuitive and efficient, whether you're modeling a simple onshore rig or a complex offshore platform. The software is fully compliant with API 4F 5th edition, the industry standard for drilling and well servicing structures, as well as AISC 360, supporting both ASD and LRFD design approaches. In this webinar, we'll provide an overview of PSE main features, showcasing the powerful generation tools that allow users to build drilling structure models accurately and efficiently. What you're looking at here is an example model, and as you can see, everything is built from members. In PSE, like most structural software, models are constructed using beam elements with assigned cross-sections. Finite elements are available, but in practice, the vast majority of petroleum structures are modeled directly with beam elements. Each member you see here is fully editable, with its own individual properties, including section assignment, material, and end releases. Depending on the type of structure you're modeling, PSE also includes full support for cable elements. There are two types available. The first is a linear cable, which behaves essentially like a tension-only member, straightforward to define and well-suited for most guide or braced configurations. The second is a catenary cable, which accounts for the physical sag of the cable under its own weight and any applied pretension. As you can see in this example, we've defined a catenary cable with an initial pretension of 100 pounds, and you can already see the resulting sag in the member. In a real project, you would simply enter the appropriate pretension value to match your design requirements, and PSE will accurately reflect the cable's geometry and behavior in the analysis. PSE also makes it very easy to create model variants from an existing structure. Once you've built your model, you can copy the entire structure, or any portion of it, and use it as the starting point for a new configuration. This can be done within the same file or saved as a separate model entirely. A great example of this is the rotation command. Let's say you need to reorient part of your structure. You simply select the members you want to rotate, activate the rotation command, define your center of rotation, and enter your angle. In this case, we're rotating by 45 degrees around the x-axis. What's powerful about this is that when you rotate a portion of the structure, all the member connectivity and properties remain fully intact. Another PSE's powerful features is its automated wind load generation. Based on the wind directions and parameters you activate, the software automatically calculates and applies wind loads to every structural member, fully in accordance with API 4F 5th edition requirements. Beyond wind, PSE gives you full flexibility to define as many additional load cases as your project requires, dead loads, live loads, equipment loads, and more, and apply them wherever needed throughout the model, whether on individual members, joints, or surfaces. Let's now walk through building a very simple model from scratch. When you create a new file in PSE, the first step is to configure your project settings. You'll start by selecting your unit system, imperial or metric, and then choose your design code. For petroleum structural applications, we'll select steel design under AISC. PSE supports multiple versions of the standard, covering both LRFD and ASD approaches. In practice, API 4F projects most commonly use the ASD methodology, which is what we'll select. Next, you can review your material. PSE comes preloaded with a comprehensive list of standard materials, but if your project requires something specific, you can add custom materials at any time either by selecting directly from the built-in ASDM library, or by defining your own and editing its properties. Once defined, the material is immediately available to use anywhere in your model. Now let's start building the geometry. Creating a model in PSE is straightforward. You begin by placing joints in the 3D workspace, then connect them with members to form your structure. From there, PSE's copy and extrude commands allow you to rapidly replicate geometry, whether you're extending legs, stacking bays, or generating a full frame from a single reference element. You can also add members manually by clicking between 2 points, or by copying existing members at a specified distance. With a few additional members in place, we now have a stable 3-sided frame. We then use the copy command to replicate it, in this case 3 times, and the main geometry is essentially complete. The next step is to define the support conditions at the base. Joints can be assigned as fixed, pinned, or spring supports. Spring supports are useful when soil stiffness needs to be accounted for, allowing you to specify the appropriate stiffness values at each support point. Another useful modeling feature in PSE is the concept of physical members. Instead of treating each segment between joints as a separate element, PSE lets you group collinear segments into a single physical member. This makes it much easier to move intermediate joints along a leg or cord. Everything connected to it updates automatically. Once the geometry is set, assigning sections is straightforward. You select the members you want to assign, then pick a section from the library. PSE includes the full AISC library, W sections, HSS, angles, and more. If a section isn't oriented correctly, you can simply adjust the rotation angle directly on the member. You can also hide parts of the model at any time to make editing easier in complex areas. With sections assigned, the model geometry is complete and ready for loading. PSE includes a very handy tool called Verify Input Data. At any point in your modeling process, you can run this check and the software will flag obvious items that may have been missed, such as unassigned sections or missing properties. Now let's look at loading. PSE gives you two ways to define your load cases. You can build them manually, selecting each load type individually, self-weight, dead loads, equipment loads, and so on. Or you can use the Load Wizard, which is the faster and recommended approach, especially for wind loads. The Load Wizard guides you through generating a complete set of load cases based on your project parameters. For API-4F wind loading, you simply specify your reference wind speed, select your wind directions, for example 0, 45, 90 degrees, and so on, and the wizard automatically generates all the corresponding load cases. If certain cases aren't required for your project, you can simply remove them before generating. Once you click Generate, all wind loads are automatically calculated and applied to the structure across every selected direction, instantly and in full compliance with API-4F requirements. Beyond wind, defining additional load cases is just as straightforward. Self-weight, for example, is activated with a single click and is applied across the entire structure. Other loads such as hook loads are equally simple to define. You select the relevant joints and apply the load directly. With our load cases defined, the next step is to generate load combinations. PSE includes a load combination wizard that automatically generates all required combinations based on your selected design approach. If the generated combinations don't exactly match your project requirements, you can adjust them directly in the software or paste them in from Excel. Every table in PSE is fully compatible with Excel, so you can copy and paste in both directions, which is a real time saver on complex projects. You can also visualize how the loads change from one combination to the next directly on screen, giving you a clear picture of what the structure is being subjected to in each case. With load combinations in place, the model is ready to run. PSE offers several analysis types: linear, p-delta, nonlinear, and more. Once the analysis is complete, PSE offers a wide range of options for visualizing and reviewing your results. Displacements, axial forces, stresses, and reactions can all be displayed directly on the 3D model. The display scale is fully adjustable, and you can isolate specific members, such as the main legs, to focus on the results that matter most for your review. Results can also be animated, which is particularly useful for understanding structural behavior under dynamic or seismic loading. For a more detailed review, all results are available in table format. You can select specific joints or members and query their results directly, giving you precise numerical output alongside the visual display. This concludes our brief overview of PSE, Petroleum Structural Engineering software. Ready to get started? Contact our team or visit our website for more information.